Rehabilitation Engineering Research Center for the Advancement of Cognitive Technologies, researching and developing existing, emerging, and new technologies. The problem: individuals with cognitive disabilities have long been marginalized by society's unwillingness to include them within their local communities, educational systems, and workplaces, in short, into the very fabric of society. While technology undoubtedly can play a vital role in decreasing this marginalization, there have been very few attempts to date to produce a coherent and sustained approach to identifying and ameliorating barriers for persons with significant cognitive disabilities through the use of technology until now.
According to the World Health Organization, over 650 million people around the world have disabilities, and over 250 million children under the age of 5 are not going to achieve literacy goals. They're going to have some type of cognitive impairment because of poor nutritional status, birth insults, chronic disabilities, acquired disabilities, etc. And so when you think about cognitive disabilities, particularly in the United States, it's 1 in 7 people have a cognitive disability across the lifespan. And that is a large number of people, and it is a problem that truthfully must be addressed.
Our target population includes almost 23 million Americans who have some form of cognitive disability, whether acquired or congenital. What does the current world of cognitive technology look like? It's exciting, scattered, some good devices. Devices are emerging and changing the world, moving in the right direction. There's greater appreciation of technology. There's a greater consensus for how individuals with cognitive disabilities can use technology.
Is that we believe very strongly that technologies, assistive technology, and in particular technologies for people with cognitive disabilities, aids in giving them independence, communication, and also to increase their level of employment, their enjoyment of the home environment, and also the local communities. It's a very important part of the overall assistive technology industry. And in fact, it's one of the most exciting areas. Cognitive technologies are moving very, very quickly, and some of them are converging not just for individual disabilities with cognitive disabilities, but also those involved in the aging population with Alzheimer's. So many of the technologies that are being developed for that particular group of disabilities also has many different involvements across multiple areas of the population.
What is the need for cognitive technologies? Persons with cognitive disabilities need information and access to cognitive technologies to perform daily tasks and activities at home, school, work, and in the community. Professionals need access to information, education, and materials for professional use. Existing and emerging technologies need to be adequately tested and developed with extensive consumer input and support. What are the perceived challenges of cognitive technology? To make things as simple as possible, focus on the final outcome. What's the impact we're trying to help them make on the world? Grant or deny access? Becomes one more barrier. Lack of awareness, how to find it, acquire it, and get the most out of it. Lack of training.
And the challenge that we face in the RERC, I think the challenge that all of us face working in assistive technology, is to both embrace those technologies for what they can provide our clients, our friends, but also to be as critical as we can and understand where those technologies fail and where those failures can put our clients and friends and family in danger. What are the points of failure? What can we do when a failure occurs so that someone is not put at undue risk?
The role of the RERC for advancing cognitive technologies is to lead the development of emerging technologies and to think about what new technologies can be designed to benefit people with cognitive disabilities. It's our role to raise awareness about the benefits of technology, as well as the opportunities that manufacturers, engineers, researchers at higher ed have in order to think about these problems and to design solutions for people with cognitive disabilities.
What activities do we plan to do? 1. Conduct product testing of existing cognitive technologies and disseminate findings nationally. 2. Conduct iterative product design testing and disseminate findings with researchers and developers. 3. Conduct knowledge translation activities to support incorporation of cognitive technologies, accessibility standards, and evidence-based practices in home, school, work, and community environments. 4. Design and develop new cognitive technologies and transfer these technologies to the commercial market. 5. Develop and disseminate training programs and materials for professionals and consumer use. 6. Train future researchers and developers in cognitive disabilities and cognitive technologies design and development. Goal of the RERC-ACT: to enhance the cognitive functioning of children and adults with cognitive disabilities at home, school, work, and the community through the development, testing, and implementation and integration of existing, emerging, and new technologies, and to create evidence-based training programs and materials for professionals and consumer use.
For this RERC, we chose 3 target populations: children and adults with developmental disabilities, people with acquired traumatic brain injury, such as returning veterans from Iraq and Afghanistan. We also chose to work with people with early onset dementia, such as Alzheimer's, and we chose them because we felt they were representative of static disability, meaning something that stays relatively constant across the lifespan; traumatic brain injury, because that is an acquired disability that has the potential for improvement to occur along the lifespan; and then the dementias, because people with progressive or degenerative disorders have lots of changes within their cognition, and we wanted to address those changing conditions across the lifespan.
Specific aims: develop and evaluate new or improved tools, methods, discoveries, standards, interventions, programs, or devices judged by expert panels and by potential users to be of high quality and to advance the field. Increase the quality and reliability of our outputs by vigorously assessing the effectiveness of any interventions, programs, or devices created by the RERC-ACT. Generate a substantial increase in the number of trained individuals with cognitive disabilities who are successfully placed in the workplace and who are successful in their jobs as a result of the knowledge and skills they have acquired through interaction with tools and technologies developed by the RERC-ACT. Improve what is available to consumers by successfully transferring new or improved assistive and universally designed technologies, products, and devices to industry for potential commercialization. Build capacity in our field by assisting fellows, postdoctoral trainees, and doctoral students in the disciplines of cognitive rehabilitation and cognitive technologies. To research and publish results of NIDER-funded RERC-ACT-sponsored research in referred journals. Extend the certified knowledge base by publishing in peer-reviewed journals the evidence-based results of our research, development, and training activities. Increase the information available to practitioners in all fields by disseminating relevant and new cognitive rehabilitation and cognitive technology information to consumers, industry, researchers, and developers, and the general public. Exemplify inclusion while we increase the accuracy and relevance of our work by conducting all activities of the RERC-ACT with an active and participatory community of persons with cognitive disabilities and their families. Facilitate the efforts of others interested in advancing accessibility for people with cognitive disabilities by providing technical assistance to public and private organizations, individuals with disabilities, and employers on policies, guidelines, and standards related to cognitive technologies. The core institutions: University of Colorado Anschutz Medical Campus, Assistive Technology Partners; University of Colorado Boulder, Departments of Electrical Engineering and Computer Science and Institute on Neurosciences. Principal Investigators: Kathy Bodine, Ph.D., CCC-SLP, Principal Investigator. Associate Professor, Section Head, Executive Director of ATP, Departments of Physical Medicine and Rehabilitation and Pediatrics, School of Medicine, University of Colorado Denver, Anschutz Medical Campus. Michael Leitner, PhD, Co-Principal Investigator, Chair, Electrical, Computer, and Energy Engineering, Professor, University of Colorado Boulder in Denver. Clayton Lewis, PhD, Co-Principal Investigator, Professor, Computer Science, Scientist in Residence, Coleman Institute for Cognitive Disabilities, University of Colorado Boulder and Denver. RERC-ACT Partners, University of Colorado Boulder in Boulder, Colorado, AbleNet in North Roseville, Minnesota, the Trace Center in Madison, Wisconsin, ATIA, Chicago, Illinois, BlackBerry, Waterloo, Ontario, Canada, the Center for Matching Persons and Technology, Webster, New York, UMBC, Baltimore, Maryland, NISH, Vienna, Virginia, Saltillo, Millersburg, Ohio, Nurintel, Lincoln, Nebraska, University of Colorado Anschutz Medical Campus in Aurora, Colorado, Beneficial Designs, Minden, Nevada. Affiliates, AbleNet, Encore, the ArcLink, Carnegie Mellon University, Craig Hospital, NISH, BlackBerry, ODLC, Quality of Life Technology Center, RERC-APT, Saltillo, Intellectual and Developmental Disabilities Research Center, the World Wide Web Consortium, A4RC, Alliance for the Advancement of African American Researchers in Computing, National Advisory Council, Dave Dichter, ATIA, Dave Dougal, BlackBerry, David Hirschberger, Saltillo, Phil Varker, IBM, Carolyn Van Howe, ATIA, Cheryl Volkman, AbleNet, Nancy Ward, Oklahoma Disability Law Center.
One of the reasons why ATIA is so excited to be involved with the RERC on the Advancing Cognitive Technologies is that this is very much about the what I would like to call the 3 Ps. It's all about partnership, it's about the products that will be out there both now and in the future, and it's also about the professionals who serve those individuals. And the research and the different projects that the RERC is working on will have a culmination in eventually going out into the world of assistive technology with manufacturing partners and also the service provider partners to take those technologies to the people with disabilities who actually need and want to use them and be involved on a daily basis.
And one of the things that I think that's very cool about this project is that they are including people with disabilities in it. And I think that's very important because we give an interesting perspective because we're the ones who live it.
Research themes: Product Testing Laboratory, evaluation and testing of existing, emerging, and new technologies. Product Usability Testing Facility to focus rigorous industry standard product testing protocols on cognitive assistive technology. Standards development, development of guidelines and standards, developing standards for cognitive technology, information technology access, and technologies. Need to create a robust and easy-to-use platform that serves as a core infrastructure for developing a variety of useful and applicable cognitive technology applications. Creation of robust and easy-to-use platform for developing a variety of cognitive technology application products. Developing a core software sensor platform to support mobile animated agents used in multiple applications.
We've developed a framework for the research and development projects. Each of the research projects is linked to a development project that might involve product testing or iterative design testing throughout the lifespan or the development cycle.
Research projects: R1, Product Testing Lab; R2, Nonlinear Context-Aware Prompting System, NCAPS, for persons with cognitive disabilities, a 12-month pilot feasibility study. R3, Effects of a mobile-based, skill-built coach technology intervention for people with cognitive disabilities. A 6-month randomized, controlled pilot feasibility study. R5. Theory and simulation-based vocabulary development for employment. An analysis of the word maturity method for adult workers with mild cognitive impairments. R6. Early developmental skills acquisition and socially assistive robotics, SARS. A pilot investigation of effectiveness.
I'm Greg McGrew. I'm with the University of Colorado Anschutz Medical Campus. I'm the principal investigator for Project R1, the product testing lab. Project R1A is the systematic evaluation of commercially available AT devices, the design and protocols for evaluation of high-fidelity AT. It's a usability lab designed to test existing, emerging, and new technologies engineered for cognitive disabilities, and it will focus on expert analysis and screening by professionals that have experience using the products and working with individuals with cognitive disabilities. It'll look at usability testing and be heavily involved in usability testing by individuals with cognitive disabilities who would potentially use the product being tested. And it will involve environment and usage testing and following up with participants using the product to determine if their function and independence was enhanced directly due to their use of the product as prescribed.
And I have a particular project that's part of a large rehab engineering research center that's all about testing products used by people with disabilities.
And what we want to do is test products that are going to be used by people with cognitive disabilities to make sure that they find them easy to use, attractive and appealing to use, comfortable to use, that they're reliable and perform well for them.
Kai is visually tracking with vocalizations. He's rolling over following the toy. He's head writing on the body reflex, which means head and body are moving together as one unit. Project R1B is called the Iterative Project Design Testing by using participatory action research methods with persons with cognitive disabilities. It will focus on engaging people with cognitive disabilities in the development activities of the RERC. This will be done through their participation in usability testing of products under development in this RERC. Project R1C is called a large-scale clinical trial with persons with cognitive disabilities to determine factors that influence their use or non-use of the cognitive technology they have selected. This will focus on issues related to abandonment, adherence, and retention of assistive technology devices used by persons with cognitive disabilities.
How can we best match person and technology? What are all of those influences and those elements that we need to think about so that basically what we're doing is conforming that product or that technology to the needs and preferences of that user, instead of expecting that user to conform or adapt to the existing structure of that device.
I am Patricia Hine with the University of Colorado Anschutz Medical Campus. I am the principal investigator for R2, the Nonlinear Context-Aware Prompting System for Persons with Cognitive Disabilities, a 12-month pilot feasibility study. This study will identify whether context-aware technologies have applications for individuals with cognitive disabilities in the workplace.
I am Jim Sandstrom with the University of Colorado Anschutz Medical Campus. I am the principal investigator for R3, the effects of a mobile-based skill-built coach technology intervention for people with cognitive disabilities, a 6-month randomized controlled pilot feasibility study. This project will investigate the effects of a mobile-based skills-built coach technology on a sample of employed adults with cognitive disabilities by comparing selective outcomes of work performance, work satisfaction, self-efficacy, length of stay in the job, and well-being to the non-mobile coach device group.
They can be on the job and not even remember why they're there or what their job is, as happens to all of us, but it can happen to some people in a more debilitating fashion, and it has a much longer recovery time. So the idea is, what technologies can we use to help people maintain their context, remember how to do their jobs, be guided in doing their jobs, possibly keep track of their tools so if they forget them in places, they can come back to get them. And they can work independently in jobs like mail delivery or janitorial or grounds maintenance, or doing different jobs in a library where they're really not involved with a team where a supervisor is right there.
I am Clayton Lewis with the University of Colorado Boulder campus. I'm the principal investigator for R5, Theory and Simulation-Based Vocabulary Development for Employment, and Analysis of the Word Maturity Method for Adult Workers with Mild Cognitive Impairments. This project investigates the development and understanding of new work-specific vocabulary to which they've been exposed.
My project is about vocabulary for people with cognitive disabilities. I believe that what's important for humans is almost all about words. It's the thing that we do differently from cats, dogs, and monkeys. And it's at the root of everything that one needs to be cognitively competent. It's probably, I like to think of it as probably the most fundamental thing there is, because everything else depends on whether you can read, write, think, and talk. And so our part of it is trying to do a better job of assessing the vocabulary that somebody already has, especially for occupational therapy, the words, the vocabulary that are needed for work and occupations.
Vocabulary is one of those things that kind of snowballs. So if the person kind of gets behind in terms of the growth of their vocabulary, it's really hard to catch up. And so some people can find themselves at a disadvantage in terms of the work opportunities they can find because they don't have the vocabulary that's expected for the job.
Vocabulary is a major barrier to employment. It might be a customer service job where folks have to be a little bit more familiar with the words that people use. Or it may be a job just where they have to know different things that are referred to so they know what to do.
My name is Jim Sandstrom, and I work for the University of Colorado. I run a project called R6, Early Developmental Skills Acquisition and Socially Assistive Robotics, a pilot investigation of effectiveness. This project will look to see what happens when young children with disabilities play with a special robot we are building. We'd like to find out if the children are more active playing with the robot than with other similar toys, and whether we can learn how to make the robot better in the future.
They deal with looking at the use of socially interactive robotics with very young children with significant disabilities. And these are the kids that typically can't play with toys on their own.
So we're trying to encourage the child to reach, and in the absence of a clinician or a caregiver to help promote that, we're hoping a robot might be a mechanism to encourage that type of activity.
Development projects. D1. Development of uniform standards for cognitive technologies. D2. Interactive animated agents platform development for cognitive technologies at home, school, work, and community. IAAP. D3. Nonlinear context-aware prompting system, NCAPS, for adults with cognitive disabilities in the workplace. D4. Mobile coach for vocational application. D5. The Socially Interactive Early Childhood Robotics, SAR, project. D6, inclusive collaboration technology for employment and participation.
Hi, I'm Peter Axelson with Beneficial Designs. I am the principal investigator for the D1 project, Development of Uniform Standards for Cognitive Technologies. This project will create standards for products that are commonly used by persons with cognitive impairments and their caregivers. The standards will address the functional performance of technologies that are commonly used by persons with cognitive impairments. Implementation and adoption of the standards will positively impact the lives of persons with cognitive impairments. Because the standards will embody universal design principles, they will have positive implications for all users of these technologies. The Standards Committee is part of the RESNA Assistive Technology Standards Board, which is accredited by the American National Standards Institute. People and organizations that will be affected by the standards are participating in their development.
We plan to examine a variety of consumer products that people with cognitive impairments use to determine what features about those products make them easier for people with cognitive impairments to use.
I am Sarah Van Vieren with the University of Colorado, Boulder campus. I'm the principal investigator for D2, Interactive Animated Agent Platform Development for Cognitive Technologies, at home, school, work, and the community. This project provides the ability to host an animated agent on a mobile handheld platform to be used anytime and anywhere in the life of a person with a cognitive disability.
Hi, I'm Julie, a talking digital assistant. For the RERC, I will act as a job coach. I am one of several digital agents being developed for personalized assistance and guided instruction when expert human help is not readily available. I am available on the web, smartphones, and tablets.
But the idea again is to provide the kind of interactive assistance for people that provides more of the human personal experience, how we think and interact with technology devices in our everyday life.
I am Mike Malonis with the University of Colorado Anschutz Medical Campus. I am the principal investigator for the project D3, which is Nonlinear Context-Aware Prompting System for Adults with Cognitive Disabilities in the Workplace. This project integrates nonlinear prompting, animated agents, context-aware sensors, batteryless power supplies for sensors, automated video recognition to create a solution intended to assist people with cognitive disabilities to succeed in the workplace.
And it's an assembly workstation, actually a couple different assembly workstations, where there's a series of inventory items that need to be selected from the respective inventory bins and then placed into an assembly area.
What I think we can contribute to it is that we give them ideas of how to use the products that they're developing, which I'm really excited about the products that they're developing, because I think they're going to be very cool and very helpful to people.
I'm Clayton Lewis with the University of Colorado Boulder campus. I'm the principal investigator for D4, Mobile Coach for Vocational Applications. This project focuses on coaching workers who move around the workplace in the course of their jobs, and it supports the interpersonal soft skills that are critical in many employment settings.
And so this means that there's some new challenges, but also some new opportunities. We can't take the approach, really, of instrumenting the place where they're working, because they are moving, but we think new technical developments will allow us, nevertheless, to provide some useful help.
We have these workstations, and in the case of mobile devices, in the real world, those workstations would need to be populated with the inventory. And so mobile devices is more of a campus-wide or a warehouse-wide work environment where items are pulled from the shelves and then ultimately placed into the workstations.
My name is Jim Sandstrom, and I work for the University of Colorado. I run a project called D5, the Socially Interactive Early Childhood Robotics Project. We are making a special robot using parts or toys you can find in many stores and combining them with a computer and sensors, which make the robot smarter. For example, when finished, the robot may be able to know how far it is away from things, know when it's touched, and might even be able to recognize a person's hand if it is reaching for something. We are building this robot to play with young children who have disabilities so they can practice using their hands.
I am Clayton Lewis with the University of Colorado Boulder campus. I am the principal investigator for D6, Inclusive Collaboration Technology for Employment and Participation. This project aims to shape collaboration technology and associated meeting management and participation practices to allow more effective participation by people with cognitive disabilities.
Our aim in this project is to make technology-supported collaborations work better for people who have cognitive disabilities. The background on this is that more and more work that people are doing is being done not face-to-face in an office or conference room or whatever, but people are working together more and more in ways where they're being supported by technology.
What do we plan to produce? Accessible, plain language consumer reports that are useful for consumers, families, and professionals. Technical documents useful for manufacturers, researchers, and engineers. Web-based resources, webinars, electronic newsletter, and email updates to over 6,000 constituents nationwide for further dissemination. Toll-free telephone access. Journal article submissions. Survey and feedback instruments. Alternate formats.
The RERC for Advancing Cognitive Technologies team is working to develop training materials. These are electronic training materials such as webinars, online coursework. It is classroom, whether it's undergrad or graduate coursework at the pre-service level. We're also doing workshops, in-services, community-based training so that we can get information about the benefits of technology for people with cognitive disabilities out as far and wide as we can so that we can teach the upcoming professionals how to research and develop these technologies, how to do clinical interventions with people with cognitive disabilities, and how to respect people with cognitive disabilities along the way.
T1, training students. University of Colorado Boulder. Assistive technology for people with cognitive disabilities. Advanced undergraduate. Disability and assistive technology devices. Undergraduate. Human-computer interaction and accessibility. Junior level class. University of Colorado Denver. Bioengineering program. Doctorate level. Bioengineering for persons with disabilities. Broadening participation in computing program, Jackson State University. Train masters and PhD students through participation in research and development projects, 7 to 13 students, 5 to 10 interns. Undergraduate and graduate courses to raise awareness of challenges in the general disability field and especially cognitive disabilities. A. CU Boulder, one undergraduate graduate class in ECEE focused on cognitive assistive technology, taught every other year. One undergraduate course in computer science in human-computer interface and interactive design with a focus on accessibility once a year. One undergraduate class in assistive technology across disabilities once a year. B. UCD HSC, new joint PhD program in bioengineering. This program will have a strong assistive technology component. C. Alliance for the Advancement of African American Researchers in Computing, A4RS, Leadership. D. Total students taught over 5 years, approximately 400. T2 conferences. State of the Science Conference. Extend the IEEE Accessing the Future Conference. Partner with annual Coleman Institute for Cognitive Disabilities Conference. Participate in annual ATIA Conference. Participate in annual RESNA RERC-ACT Conference. T3 webinars. ATIA Usability Analysis. 1. Generate webinars to disseminate the findings of our usability lab. product usability tips, clinicians and public, product choice webinars, technical presentations for engineers and designers, T4 usability testing, usability testing protocols, providing environments for usability testing. Through the Usability Testing Lab, we will be training students and clinicians in usability testing. This capability does not exist, to the best of our knowledge, in a university setting and is rare in industry. This will be a major benefit to the community. Measures of impact: 7 to 13 students working on RERC-ACT projects, 380 to 400 students exposed to RERC-ACT course content, 1,500 attendees of RERC-sponsored and co-sponsored workshops, and 1,000 in related conferences and webinars. 5 to 10 research interns trained, 2 to 6 students from underrepresented populations, including students with disabilities.
Our dissemination efforts range from our quarterly newsletter to peer-reviewed journal articles, books, book chapters, product brochures, anything that we can get into the hands of the general population so that we can let folks know that technology does work for people with cognitive disabilities.
DP1 newsletter, distribution list of over 4,000 individuals on a quarterly basis. DP2 website, http://rerc-act.org. DP3 conferences, ATIA, Chair Cognitive Technology Track, Manufacturers Forum. DP4 journal publications, peer-reviewed journals, Traditional Engineering and Computer Science, High Quality Conference, Special Journal Issue, State of the Science Conference. A complete list of all publications are listed on the website.
One of the highlights of the RERC for Advancing Cognitive Technologies is our collaborations with mainstream commercial manufacturers. We are working very closely with REM, and that's the BlackBerry company. We are also working with IBM as an enterprise partner within our RERC initiative. We have begun work with Nokia, Cable Labs, a number of manufacturers of mainstream products who are beginning to see and to recognize the need to improve the accessibility of their products for persons with cognitive disabilities. One of the things that makes our Rehab Engineering Research Center unique from many of the others is that we made a conscious decision to include both commercial mainstream manufacturers as well as assistive technology manufacturers within the entire operation of our RERC. So whether they're serving on the National Advisory Council or there are partners within several of the research and development initiatives and even some of the training and dissemination initiatives, we felt that it was critical that we start from ground zero with the manufacturers, the people who might commercialize the technology that we're inventing and researching, and have them an integral part of this so that when we develop something within our RERC, there's a home for it and a place that we can get it out into the worldwide community.
I'm grateful that Kathy asked a number of manufacturers to be involved in the creation of the first RFP for the RERC, which I think makes this RERC a little bit different, although I haven't been involved as intimately with other RERCs. But the manufacturers have been involved since the beginning to make sure that we can bring our expertise of bringing great thoughts, great knowledge, great products to market and to be utilized as much as possible. So I think the blend of what the RERC is doing along with partnerships of manufacturers really allows products to get out there and allows the implementation to be as effective as possible. And that's the bottom line for creating better solutions for people with disabilities.
DP6 standards. We will extend our previous work in standards with a focus on web-based standards to decrease barriers to employment and participation by people with cognitive disabilities in the modern workplace. DP7 technology transfer. A. Expand our activities to include close cooperation with the Knowledge Translation for Technology Transfer Center will provide new ideas and methodologies for tech transfer. We will continue to work closely with the University of Colorado Technology Transfer Office. We are excited to use the Technology Transfer Plan of RERC on accessible public transportation as a basis for our new plan. B. 2011 Product Utilization Support and Help (PUSH) Award recognizes the NIDER technology grantees who are using best practice approaches to development, transfer, and/or production processes.
For our tech transfer, we're very fortunate that we work very closely with our University Tech Transfer Office. They support everything that we do, including the transfer of technologies that may not be a complete financial home run, but have the benefit to help and change the quality of life for someone with a cognitive disability. We are working very closely with our NIDER peers who are engaged in tech transfer efforts, and our goal is to get the products that we research and we develop out into the hands of those who can benefit from them.
What will our short-term impact be? Researchers and developers will have greater appreciation for cognitive accessibility needs in assistive technology and mainstream technologies. Evidence-based usability research information will be available for consumers to use when making technology choices. Knowledge-based information resources will be available for researchers, clinicians, and developers. Data. Number of attendees at conferences, webinars, and other events. Feedback from participants. Survey of materials utility. Increased tools availability to support people with cognitive disabilities in a variety of employment settings. What will our midterm impact be? New standards developed and adopted by the international and national standards boards. New technologies will be transferred to the commercial marketplace. Trained researchers and engineers entering the workforce. New strategies integrated and efficiencies are achieved in employment outcomes for persons with cognitive disabilities. An increase in the number of people with cognitive disabilities in the workplace and an expansion of the type of positions they can hold.
For having this be a person-centered project, having it best meet the needs of that individual, and hopefully bring to bear all of the talent that we have here.
These standards are going to enable the creation of consumer products in our society that will be more accessible to people with cognitive impairments. It's also going to be just helpful in general to allow products to be helpful, to be more productive and more safe, and to give more independence designed for people with cognitive impairments. And in general, people with cognitive impairments have really been neglected in our society with regard to accessibility issues. So this is really going to change that situation.
What opportunities are there with cognitive technology? Identifying what cognitive technology looks like, developing a visual understanding of cognitive technology, leveling the playing field, opportunities override challenges, turning any challenge into an opportunity, motivation by everyone, staying connected through technology, and greater access to activities.
I would just like to thank the RERC for the work that they have been doing in the area of cognitive technology. I really encourage them not only to advance these technologies, but to really make them known out to people from across the country. I think the more people that are knowledgeable and are involved in this process, the faster the rate of progress.
What is the future for cognitive technologies? Exciting new projects, major shift in how individuals use technology to enhance their lives. Information is powerful and can be understandable by everybody, delivered in different ways.
I think there's many opportunities for students, especially, to get involved in this area. There's something new I think most students haven't thought of. Maybe I can participate, maybe I can help here. And I think also for people that aren't necessarily directly involved, I challenge everybody to think outside the box. If you can you might have talents, abilities, things that that you don't think would fit, but your skills might be very useful in the whole area of cognitive technology. Maybe you don't have the computer programming skills or some such thing, but you might have some other ideas that could be extremely useful.
Our goal is to have a tremendous impact in the field of technology and disability with specific emphasis on cognitive disabilities. When we are successful, we will know we're successful because people with cognitive disabilities will be successfully going to school, they will be working, they will be living independently, they will be recreating along with everyone else, and they will have a much higher quality of life. And they'll be able to tell us that, and we'll be able to see that and measure it. Whether it's through financial outcomes for people, whether it is through quality of life initiatives, we'll be able to see the impact that our RERC has had on these individuals.
To contact the RERC-ACT, call us at 1-800-255-3477 or email us at rerc.act@ucdenver.edu. Visit our website at www.rerc-act.org. Mail us at RERC-ACT, University of Colorado, Anschutz Medical Campus. Assistive Technology Partners, 601 East 18th Avenue, Suite 130, Denver, Colorado, 80203.